So, hello guys. Today we are going to look into the GhostBox development and let's see how the GhostBox is moving ahead. So first, I will just open the GitHub repo. So this is my first devlog kind of, and I'm just showing you what I'm doing currently and what is the progress on my GhostBox system. So basically, I'm doing the unified virtual machine where I'm pulling the RAM and GPU resources from multiple machines on the network. So it's just like a GPU over IP, RAM over IP type of thing. And I want to use this to run the LLM model on my old laptop using my old laptops and all because I have more than three laptops with me, and there are GTX graphics card at the top at that time I have on in each of the laptops. So I want to use these resources instead of going those to the waste. So let's show you what I'm doing right now. What is the status? So basically, guys, I created a GPU server, and the GPU server is basically mapping the GPU memory for us, and we are using that in our host side where we are creating our VM. And basically, this code is using NVML wrapper where we are using NVML wrapper to get the GPU uh, compute and use it on our host side. So basically, this is a host, and I created three types of files over here where I will check in these files today itself after this video. When I will share it, you can go and check these details. So this is GPU shared QMA where only GPU and the current system's RAM it been shared. Where I am currently going for the port GB, 5 GB of the current system's RAM and 8 GB of the GPU. Then we have this QVME part where we are only using as a RAM and not a GPU, and we are going for 32 GB of a RAM from the shared systems. So I created a combined version of the both also. This is also starting, but there are some bug fixes I need to complete. I will show you how everything is working and how it will look. So let's start with the GPU server. So I'm building the GPU server, and you can see our memory sharing is started because currently I have GPU on this laptop only, so I don't need to go and log into remote server. I'm just showing you how these two process communicate and create a QEME for us. And let's start our VM host. So currently it's preparing the memory, the background. As you can see, it has been sent and our QEME console has been started. Now we will just wait for some time. There are some end of early end of file exceptions I'm getting on the GPU server side, but I will be fixing it in the future. So we can see what it will do. Before that, I will just expand this a little bit and show you the NUMA information. So here, if I type info NUMA, and you can see we have 8 GB of NUMA Node 1 and 5 GB of. So this 8 GB is actually our GPU. So let's go back. Uh, just a second. Mm, no, much. So I think something has happened. I will just restart the host and we will see. So our grub bootloader is started. grub bootloader. Now we can see that console is starting. Instead of going to the information, I will just wait for it. Now booting from the hard disk, the mapping is done. And currently I'm doing pooling of the memory on the file, and here our Ubuntu is started. And now currently what we are doing with the QEME, we are actually mapping our shared GPU memory as a RAM right now into the memory. So you can see we have 8 GB shared RAM coming from our server. So it's starting, and I will also show you what problems I faced while implementing this, or after completely implementing the project when I execute both things like CPU and the GPU together. So right now, if I only want to get the GPU from the another machine, then it will work. And if I only want to get the RAM, then it will work, but it will not booting the QEME operating system properly with both the together. So right now I am thinking about zero copy mechanism, or just going a little bit deeper into it and creating a hardware driver. I will also show you what I am doing right now. So this part is at least completed from my end, and I kind of analyze how it is working, what I should do, and I research some things regarding it. So I just need to focus on the future development. So I just need to change some things. Uh, I think like you can see, it's loading, but it's very slow, and I don't want this machine to be slow. So while it gets loaded, I will show you what is the future of the Ghostbox, what I'm thinking about it. So let's get back to the browser and I will show you. Yeah. So currently I'm only focusing on the what we say Windows. So right now I'm thinking about creating a Windows driver. Just give me a second. I will connect this. Okay, I don't have USB port right now. Okay. So, so currently we have one host system. We can call it host, and this host is calling for the resources on the GPU systems, and the GPU systems are sharing the CPU and GPU over uh, and the RAM over to the host on the network. So we are currently using Tokyo Crate for this on the Rust, and I want to improve the performance of it. Right now, you can see we still not have loaded our completely our system completely. So we want to improve the performance. I want to improve the performance. So right now, what I'm doing over here. So I thought, what if I just go to the kernel level? For example, this is our kernel. Then we will create one another label. We will call it user mode. User mode. We will call it a user mode. And suppose this user mode actually interact with the kernel. And what if we will use WDDM? So Windows Driver Development Model, and create a virtual GPU on the host machine. So suppose I wanted to, let me just, yeah. So host machine using virtual GPU. So basically, uh, and this uh from this level, we will open raw socket communication connection to the machines which we are actually requesting the resources from. So this kernel level communication from the machines, suppose G1, G2, and these are the GPU machine where it have 8 GB GPU each. So we will get totally 16 GB GPU over here, and it's basically the less than microsecond, 1 microsecond. So these all things will be basically improve the performance also and provide a, instead of depending on the QEME like structure or any VM like structure, we can do it. Yeah, but I'm thinking about kernel level directly. So if we will develop a Windows driver which will host a virtual display adapter, and this display adapter we will use directly because on the kernel level we are actually using raw sockets to communicate and get the resources from each machine, from each resource available machine. So totally we will get 16 GB of a GPU on our host machine. So guys, I will just show you my basic plan moving ahead. So now I will show you the what is the progress regarding it. Like still you can say it is not loaded. I am still waiting for it, and yeah. Now you can say we have the Ubuntu loaded, and if I click, it's still very slow. Right now my GPU is also used by, like, this is the problem I want to solve. Like you can see, if I run this without recording the screen, I will get a little bit much smoother experience over here. But right now it's lagging itself. The work. So I want to solve this problem basically. So this lag, and use some low level tactics to get everything. Like I can also disable some specific algorithms from the TCP IP layer. So we have some TCP IP layer algorithm which actually not needed IP, and we can create a compute only, not the complete display adapter, but compute only display adapter, which will be using shared resources. So let's see how it will go. Now you can see here. Yeah. So this is loaded, but it is taking time. Basically, what I wanted to show you, I shown to you. I just close this, and now what is the progress? So basically, I created one iOS driver, Windows driver. I just named it KMDF driver. It's a basic sample driver. I wanted to test how everything is working. So I created one test app also, which is actually calling our driver and getting the output. So basically, we are only creating IOCTL GPU compute, nothing else. We are only going for the GPU compute part. And if you see the basic driver in 3, we are creating a WDF driver right now, and which is not completely a display adapter driver. I need to go with the DX libraries and DX part and access the DX system kernel part to and register my driver over there to uh, fulfill the stack requirements to present it as a display adapter. But right now I installed this. As you can see over here on my Windows machine, I am in the test mode right now. So because of the signing, I need to sign the driver. And if I go to the manage, yeah. So if you go to the system devices, now it's in the system devices, it's loading from the start. We don't have any overhead automatically connect in the network. So we are using 0MQ to capture available hardwares in the current network. So it will totally work on the offline mode, guys. Nothing online is required. You just need a connection on offline LAN connection and connect every system in the same LAN network. It will be also used on the internet part. But if I show you my driver, so you can see the device I have created. So this is my GhostBox device, and this device I want to use from now to communicate with other hosts. So now what we are going to do, we will create two types of. Let me just clean this up. So what we will do, we will create one virtual GPU on host machine. This GPU is actually communicating to other GPU machines. Mm. And if we see over here, they are going to communication over socket, raw sockets, network sockets we are going to use, and these will communicate on the kernel level, and every GPU system is also running kind of a driver, custom driver, which is sharing GPU resources over the socket. So this is my plan, and currently I am succeeded with the base driver creation. So now my base driver is created. It is also installed, and if I run my test app, mm, 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 yeah, you can see I am getting hello GPU from my driver. So my test app is also working. We are just going for the uh, device, then we are calling our IOCTU compute method from the device IO control. So basically, we are successfully able to connect with the Windows driver using this. So now I will need to implement the actual display compute part over here. So it will be identified as a display adapter, not as a custom system device. So these parts are remaining, and mostly I will complete these in next 2 weeks and present you the other part also. So thank you guys, thank you. So this is all I want to show you related to Ghostbox, and stay tuned. I'm going to post this type of video every 2 weeks to show you the progress of the Ghostbox. What exactly I'm doing, what I researched, what I learned, and how fascinating the technologies are. What we can do without depending on anything if we just thought properly, if we just go in the proper directions, we can achieve anything in the technology, I think. Maybe I could be right, wrong, but yeah, I think everything is achievable in the technology. At least not in the core part, not in the science, computer science part. We need to do the research over there, improve the things, but at least what is developed on what platforms, on the what base we are developing things. At least we can develop anything over there. Thank you.